Now, for the next step, we will think about how the light propagate in a material case. And then, as we've already mentioned, inside the materials, we will have a extra electric field or magnetic field by the polarization and magnet. Then V equal not only the field displacement in vacuum, but also we will have a polarization, which is polarization inside the materials. As I mentioned, if you have an object and light coming here, inside there's some polarization induced. And then the other term is inside the vacuum, still epsilon zero E field, but you have extra polarization. And similarly, magnet also, magnetic displacement also mu zero H plus, but mostly we will just ignore the magnetic field effect. And now we will think about for non-metallic and non-magnetic materials case, then the current equals 0 and charge is 0 and M equals 0. In this case, Maxwell equation can be described again, divergence E equals 0, divergence H equals 0, and the rotational E equal minus dB dt, and the rotational H is here the not first maybe should white. Equal I equals 0 and D equal now D equal epsilon 0 E plus P. And again, this H can be little like U0 B. And again, we will differentiate the equation 4 to obtain the rotational dB dt equal d squared and epsilon 0 E plus 0. And then similarly, we can just import the substitute this dB dt by using the equation 3, and which gives the rotational maybe minus rotational E equal And we use a C in this case, C squared over D squared T squared plus 0 D2P and DT2. And again, using the squared divergence E plus Laplacian parameter E. And then finally, we could obtain the Laplacian parameter E minus C squared over 1 D2E D2 equal 0 dt d2p dt2. So you can notice that as a final result, if the right term is 0, it's just a wave equation. Well, this one is the second derivative of p with respect to time, meaning the polarization. So if you have an object, some sort of the polarization oscillation or some sort of some motion or shape change, whatever it is, the polarization could induce the electric field, right? So this is a kind of the source of light. So inside the material, polarization, temporal change of the polarization gives some sort of the electric field wave. So which is this equation means. And then this equation is called propagation equation.